Hey, everybody, we are back again. We are having a hangout today with Trouble About Our Trouble. We've got our Patricia here. Obviously, there's me. And we've got E1. We've come together today to talk about stars in the southern hemisphere. Hi, guys.
Hey, hey
Hi
everyone.
everyone.
Yeah, so me and Trouble talk quite a lot. And actually, she's mentioned you to me through her. So she's very, she's very caught by her stars, aren't you, Trouble? And so,
Yeah.
yeah, explain how you met E1 then.
God, I don't know how we met. On PPC Hangout. Is that what it's called, E1?
They've changed the name on it so many times, I'm not sure what it's called anymore, to be honest with you. But yeah,
No.
that's where we met. Definitely.
Yeah, so it's just a group of flat earthers on YouTube, really.
Yeah, but he's a bit like music to your ears because you're studying these stars daily and they don't add up to what everybody says. And now you found someone that talks a bit like you.
Yes, yeah. Well, because I'm in Australia, obviously, and I can see that the Southern Star celestial stars, is that what they call it? And well, no, that's it, the pole stars, celestial pole stars. And so there's not just Polaris, but there's Sigma Octantis. And the southern stars revolve around that. They don't revolve around Polaris. And then you've kind of got this where the two pole stars meet in the middle, there's like straight lines. The stars appear to go straight across the sky. And oh my gosh, sorry, I'm sorry. It's really early here and I've only just woken up.
Yes, I'm really sorry, Trouble. We realised that our clocks went back like a couple of weekends ago. Well, a couple of weekends ago now. And actually it's changed the time again, and that's why we're an hour out.
Oh,
So sorry
well,
about that. And just so everybody knows, it's 7 o'clock in the morning and I've dragged Trouble out of bed. Sorry about that. Anyway,
it's 6
sorry.
o'clock.
6 o'clock.
Yes.
Oh, I'm so sorry. What a nice girl you are.
Definitely. My goodness.
I had the alarm set for 6 because I had a feeling to be out by a little bit, but yeah, I expected to be up by now. Anyway.
Yeah, anyway, so sorry about that, Trouble. But back onto this then. I'll give you a hug afterwards. Back onto this then. So your star trails don't match up to what they say.
No, and I've been mumbling about it for a while, and then E1's turned up and started talking about analemmas, and that's where this if you photograph, you'll have to explain it, E1. I'm still asleep.
Oh, no problem. No problem.
Go for it, E1.
Well, do you want me to start with the Analemmas, or would you like me to start with like how I came up with it and how it all goes together?
Yeah,
Okay.
yeah. No, you do your thing.
Well, actually, Trouble really has to direct today because she's the person that really wanted to have this. Well, no, we all wanted to have the hangout, but she's the person that was talking about it, and I don't know so much. So yeah, up to Trouble. What Trouble says today?
Yeah, no, yeah. Let E1 go for it. He's got it all. A nice presentation. So yeah, go for it.
So I even before I started with Flat Earth, I knew something was wrong with what I was being told about the shape of the Earth, the maps that we see, and how the weather moves across our plane of existence. And what I was doing is looking at high altitude weather balloon images or satellite images, whatever you want to call it, for weather. And I'm not sure if you guys can see this. I turn it on so you can see one of the polar weather balloons that you can see North Pole, all of North America, and then South America with a little bit. I mean, you can kind of pull in England, Scotland, Spain, and stuff like that. But what I was starting to notice is that South America was skewed so far off to the east of what I was normally shown on America that it wasn't south. It was directly east
It has
of
to be
America.
because
And you can see this right here.
Brazil is only 4 hours behind the UK, and yet it takes 24 hours to get there almost, but it's only 4 hours in time zone.
Exactly. And things like this, like, okay, so you can see that the way that everything's curved up and how if you're in New York, it'd be directly north to go to England, not east. It's directly north. And just all kinds of weird things that I was starting to see. So I knew that the maps were wrong. There was all just kinds of things that didn't add up. So I started thinking about how could I figure out what I could use as a marker. And I'm going to show you a regular map that you normally need, you know, on the ball. But this is just to give you a reference of what I am. So, oh, shit. Hold on. Okay, there we go. So if you see on the regular map, and what I'm trying to show you here is, I was looking for markers. I was looking for something that I could use to mark either anything, the center of the Earth, the outside of the Earth. And what I thought was to look for was the megalithic structures around the world, like Easter Island, the not Machu Picchu, but
I
the
just say
Incas, the Aztecs.
we did some of this. Yeah, I know exactly. Yeah, carry on. Yeah, as a group we did.
Okay, so if you look here's Easter Island. Here's where the Mayans, the Incas, or the Aztecs, the Incas. You've got Egypt. Then you start getting into Iraq for like Mosul and Mesopotamia type stuff. Iran, all the way down through India. Philippines, all the way to Tonga. And each one of these positions here are megalithic structures that are over 10 tons because these ones are devoted to the sun. If you look at it on this map, it makes a pyramid, correct? I mean, you see that it makes a triangle. And it doesn't really have anything, it doesn't really show you anything until you start taking and putting on the Tropic of Cancer, the Meridian, and the Tropic of Capricorn. These structures, each one of them, are huge 10-ton or 100-ton blocks. So these are megalithic structures.
Right, cool.
Anything with the foundation where the blocks are over 10 to 20 tons per block is what I was looking at. And they're devoted to the sun. The other thing that these ones show is if I take and you look at these lines, the blue, red, and the green, and that's what I was saying is the Tropic of Cancer, the Meridian or the Equator, and then the Tropic of Capricorn. And if you take that and you move it over to my map, in fact, I'll just bring it up over here. That's where I think the Tropic of Cancer, the Meridian, and the Tropic of Capricorn are, as far as the way that my map is depicted. And if you take those exact same, that line that I showed on the other map, my line is a direct line through the center of what I'm depicting the Earth to be. And if you follow it through and you look at, you know, Tonga or not, I don't want to definitely pick out exact locations, but these ones are the ones that fall directly on the track of the sun. And if you look at Tonga, the ones in the Philippines are basaltic megalithic structures, the ones in China, India, there's Petra, I mean, it just goes all the way across, all the way over to Easter Island, and each one of them falls on a track of where the sun would be on the summer solstice, the equinox, and the winter solstice if you follow it out. And what I think they were doing, and by building all these megalithic structures, and this is just my opinion here, that they were able to mark down exactly where the sun was at a certain time, and then they could use Pagatherm's equation to figure out exactly how big the sun's track was at the summer solstice, the equinox, and the winter solstice. But this isn't so much what Trouble is wanting me to get at on this kind of stuff. I'm just getting you up to how I started putting this map together, or putting this idea together, if this is what it looked like, was that if you take and you put, like, how can I put this? You see these three rings, and I couldn't figure out how everything would be working and put together until I started looking at this as an electric universe. And if I show you what a coil I'm just going to show you these first. Electricity in a coil. I don't know if, can you guys see this or not?
Yeah, we
Yep.
can see it.
Okay, so electricity when it runs through a coil or a wire, for example, a wire would be like this. If you have negative on this side, positive on this side, the rule of thumb says when the electricity that's powering through electromagnetic current or flux will rotate in a anti-clockwise or a counterclockwise rotation around the wire. If you take that wire and you curve it into a coil, you get the same rotation. It's the same direction of rotation, but you have now bent the coil or the wire so that you get opposing rotation, but they actually do the same thing that the stars do. They converge and diverge on a plane, on an actual flat plane. And you can see it. How can I put this? Sorry guys, I gotta move the cameras around and shit. You can see this with some star patterns like what trouble does. This one's not troubles, but this one's from the equator, to where you can see the two disks in the sky above you are just like the flux of an electromagnetic engine or flux going through a wire. And you can see that you've got the two spinning disks that they converge and diverge. I was saying if you take a coil and you throw iron filings in a coil and electrify it, this is what you actually get. Does it? I'm not sure if you guys are seeing it. If I'm breaking up, then
No, you can see it.
it's showing you
see
what
it now. Yeah.
what iron filings will do when you electrify them with inside of a coil, and it kind of gives you the exact same pattern that you see in the sky and stars. You get two disks with a converging and diverging, and just like that is kind of what I was trying to get at. On it. But so if you take this map and you put the actual, what I believe the star trails look like, not so much what they show us as being this, I think, just like an electromagnetic field running through a coil is the same thing we have with the stars going through the southern star. If you see what electromagnetic flux would look like moving through a coil, this is what the flux would look like if the coil was running through. I'm not saying that there's wire connecting the northern pole to the southern pole. It's the atmosphere itself. Our atmosphere with electricity, and you can see it with the aurora borealis, and just the sun and the stars themselves. They're all electric. They're all electromagnetic. As far as the Analemmas go, we have to get away from the stars for a second, and just if you look at what I think the sun and the moon are riding on, it's these three magnetic rings or electromagnetic rings. We can represent them. You see them as the Tropic of Cancer, the Meridian, and the Tropic of Capricorn. But if you look at them as just the rings they are, and you guys know what the Analemmas are? I'm not sure exactly if you do, but the Analemmas are just the positioning of the sun and what they look like at a certain time of the day. Every 24 hours in the morning, let's say at 8 o'clock in the morning, you would take a picture for every day for a year, and it would look like this. So this one's the sun, this one's the moon. You'd have to look to the west to get this picture. This one's every a 30-day cycle. The sun is going to be a 360-day cycle. This one you take a picture every 7 days. Actually, it is for 365 days. This one's every 2 days for 30 days. To get this Analemma. And what it is that you have to look west or east to see the sun, west, to see the moon's analemma, and they actually make this 8 pattern. And that's where I got these rings, is because in order for the heavenly body, is what I think it is, an electromagnetic, either a magnet and tungsten sphere or an aluminum plate, whichever you want to go at it. They're moving because they're moving through an electric field. And if you look at these fields themselves, that's why they show the analemma, is because if you looked at these three rings from the side, if you tilted it up, you would see this, and that's how you get the analemma, is the sun's riding and the moon are riding on these 3 rings around its circuit to make its analemma. And if you can see that, the reason you would see the analemma is because if you're here, and the sun and the moon are rotating rotating above your head around. If you're sitting here and you look to the east in the morning, it'll actually give you that 8. If you look during the noontime, it just gives you a line. And I can represent this for you so you can see what I'm talking about, I think. Let's see here. This is what a representation of a GIF or an animated image of an analemma going across the sky. Every one of these lines going across is a 1 day, and then the entire circuit of 365 days has shown you that analemma tracking across the sky. I hope you can see that.
Yep,
Yeah,
yep,
we can.
okay.
Yeah, we can.
Okay. All right. Let me go from there. Let me grab my thing here. Okay. Shoot, I don't know exactly what I should tell you now about. I can show you as far as it seems to be that if when you look at the difference between the analemmas of the sun and the moon, if you look at them, you see that there's a crisscross. And this would be, people think that this right here, this position is the equinox, the spring and the fall. But it's really not, because if you look at the moon, look at where the positioning of its equinox is, or its cross. So if you look at this, and they're both riding on the same, 3 rings going around, or 3 rings, and they both are the same size in the sky, and they go to the same positioning, what would make it to where one was at a different cross, one was higher, one was lower? And the only thing I could come up with is that they're made out of 2 different materials. One's a magnet, one's aluminum, so that they ride at a different height. They move at a different regulation or a different cycle. And that's how we get our, that's
Can
how
ask
I
you
believe.
something? In the morning and in the night, when the sun is low on the horizon, you can see through it.
Yeah.
So what did you say it was? Aluminum?
The moon itself?
No, the sun. When the sun is low on the horizon, so like when it's appearing or disappearing, when it gets really low in the sky, people film it and they can see through it. The sun, that is.
I don't, I'm not going to say that this is the exact definition that has to be, but it looks to me like when you see that line or that hovering of the sun, it's an optical illusion. It's atmospheric lensing, because it's not like the moon, like when you see up in the sky at let's say halfway through the day, you can see the moon's lit up on one side, but you can see it's the same color as the sky on the other. The same effect I think you're having with the sun. I don't think it's disappearing so much, but I do know what you're saying. I mean, I don't attribute that to being see-through.
Well,
I would why?
we've had someone on the channel who's filmed it, and you can. It looks like it's really strange because I actually thought the arcing underneath the sun was just it's like a reflection of what's going up. But actually, when you zoom into the picture, it's actually a corridor effect. So it looks like a circle, but it isn't. It's a corridor effect to the sun, and then this person filmed through the sun and can see things the other side through it.
Wow, I haven't seen that.
I've
Wide
never
awake.
seen that. Yeah.
Oh,
Wow.
It's wide awake, and he's not the only one. I mean, Robert's done the same. Robert Force, he's filmed, and you can see through the sun. I was just saying, I'm not disagreeing with you, by the way. I'm just saying, what is it?
Oh no,
What
for
is it?
sure. No, I just never seen that.
Yeah, they're filming over water. I think water might make a difference because they're filming over water. But anyway, carry on. I really like that picture you had when you put it over the top and you had the two grids going south and north. I like that.
You talking about the star trails?
Yeah, well, you just put a big picture up and then you went a bit, but yeah, I like that. Anyway, carry on. Sorry, carry on.
Well, no, I was just going to show you one last thing about the whole electromagnetic, and it kind of goes along with it. I call these the abnormalities, and everybody else will know them as the Bermuda Triangle, the Dragon's Triangle, and then the other one nobody talks about, but I believe is there. But you can see this triangle. In the regular map, they show you the Bermuda Triangle is just right off of Florida. The other one is just right off of Japan and below, I guess it's just right off of Japan, really. It's where the Mariana Trench and all that kind of stuff is, but they don't have a reasoning for why it's there. And what I come up with is, on my map anyway, it's exactly 120 degrees from the north center to the Dragon's Triangle, then 120 degrees to the Bermuda Triangle, and then 120 degrees back, and it makes a fucking triangle. And so that's the thing that made me think there's got to be something to this, because this all works the exact same way an electric engine works. The electromagnetic flux, the rings.
Is this a 0 point that you found, like 0 points to make your triangle?
Well, it's because of I don't exactly know what you mean by that.
Well,
what do you mean by that?
There's a 0 point off of Africa.
Yes, and it's actually off.
So I just yeah.
It's actually off of 33. If you want to know the positioning that I went off of for my center, is 33 degrees north by 33 degrees east on our latitude and longitude on the normal map. And where it is approximately 30 miles east of Jerusalem, which is just kind of weird, but I mean, that's what I didn't pick that. It just worked out that way. But yes, there is a 0 point, but the triangle itself comes off of just because the 0 point is, and it actually worked out to hit those 2 points perfectly. So here, I'll put that. I'll put the star map back up on there because it actually does.
When you look at your map, the way you've done it, it makes me think that they've always been telling us that there's missing land in Antarctica, or we think there is, or even at the north. But maybe the missing land's to the right. Because it looks like it's flooded, the land there.
Yes.
And they're all islands. Yeah, I like that.
There's another reason why I think all the land is off to the right, because, okay, so, or to the left. I mean, it doesn't matter. It's all over here, all over here. All of this has all been taken away from our maps. And the thing is that if you look at a regular, like, let's say the globe, over 50% of the globe is the Pacific Ocean. But if I show you a map, if I grab that map and I put it up in front of you, right? Do you see 50% ocean in the Pacific? I sure don't. And the thing is that the actual land mass here is literally 40% or 35% of the world, but they don't show you that when they show you the maps. They show you it being almost 70%. It messes everything up when you start really showing yourself what you see in the sky and what you see on the ground as opposed to what they show us. Man, nothing's holding up.
Yeah, well, I like your map there, because to me, it now makes me, I never thought about it, just looking at your map. It was like, yeah, look, it looks like there was more land and it's flooded. To the right, not to the bottom or the top, but to the right. Yeah, well done.
And so these two star spirals that are in the sky, where they meet is called the celestial equator. And that's what I've been most interested in. And I was hoping to get everybody to do as much footage as they could of the celestial equator, because I think then we can place the land underneath it, depending on where they are to this celestial equator.
Yeah. And that's kind of how I think you're going to be able to figure out where we're at on the plane, or like you say, what it looks like. Because if you can see up above, so if I start measuring out on maps, there are lots of places where the same distance, like for example, if I measure out San Francisco to St. Louis, it's approximately 3 inches on the map, but it's 2,100 miles in reality. If I do San Francisco to Fairbanks, Alaska, it's the same distance in inches, or, it's still 3 inches on the map, but the actual reality is 3,400 miles. It took me 2.5, 3 days to drive from St. Louis to San Francisco, but it took me almost 7 days to drive from Fairbanks to San Francisco. And they're at the exact same distance on a map. And there's so many different things that are wrong like that on the globe.
Yes, you know something? I've thought about it. I think the UK is bigger than they're saying it is.
Oh, yeah. Yeah. Yep.
I know what you mean. I understand that. Yeah. I don't think we're the widest country, but I see the same thing because of the amount of hours it actually takes to get. I mean, it takes about 8 hours to get to the top. I know we're not as big as you, but they're making us look so small. But I think we're bigger than they say we are.
See, they have Australia and America around the same size, but I don't think it would take 7 days to go across Australia. I think it only takes like 4.
I have to say, with my research, the UK is lying on its side as well, with how the light leaves Scotland and how it stays there longer in the summer. So we've got to be lying on our side. Just with the way I've just done 3 tests, and it just all seems to go back to we're lying on our side a bit.
Well, that's what Ease Map's eventually done. It's kind of just twisted the land around a little bit.
Yeah, and do you know what? You can do it on your phone, on the app. When you get the world map up, what you do, because our phones are touch phone, aren't they? You put your finger on it and you twist it, and then everything twists round. And I can't say how far around it is, but when you can do that with your finger, I'm thinking, oh my God, that's it. Because that's what we need to do, is twist it. Then you've got more of a clear map of what we live on. Because that twists America round, it twists Europe round, and it would twist us round. You just twist the map. You can do it yourself on your own phone.
The only problem is that you can only twist the position of the entire Earth. You can't. I mean, I know you're right. That's what you need to do, but you can't twist like Australia away from South Africa. I can't, and that's the thing that I think we need to do is.
I do understand what you mean. We've sort of worked out that when they say north, it's always going to be north where you are. What I mean is not you, Trouble, because you're in the southern hemisphere, but in the northern hemisphere, you get to America, their compasses, they'll say north is wherever it is when you're there, and then the UK is the same, but it doesn't mean they're all actually, it's everybody's north, and everybody's got a different north probably.
Well, and that's something I can prove, and not so much prove to anybody else, but people should be able to prove it to themselves, and I'll show you why. Because if you live, let's say you're in England, for say, you're going to be able to, okay, so I'm pulling up the star maps. This is in the, can you guys see it, or am I breaking up?
No, I can see it.
No, you're okay.
Okay. So this is the North Star. This is in the desert in Arches National Park. You're looking east. This is going to be the south. This is going to be the north. This is Polaris. Sigma Octavius is down here. And the funny thing is that you, in North America, you have to look east. Or I'm saying, if you do look directly east, You can see the Polaris, the northern star, in your peripheral vision. You can actually see it without having to turn your head. But if I turn west and I do the same thing, I cannot see the northern star. You in England most likely can just barely get it right at your peripheral vision because of where you're positioned on the plane of existence. The Polaris is going to be directly, if you're looking east or west, it's going to be directly 90 degrees. But somebody in like China or, for example, Trouble looking at Sigma Octavius has to look west in order for her peripheral vision to be able to see Sigma Octavius looking directly west. And that actually can show us that our positioning on the plane changes the movement of the stars as far as the angle of where the northern Polaris or the southern Sigma Octavius is in your relation to where you are on the plane looking at the stars. For me, the northern Polaris is 10 degrees off of north, of true north. And it's that right there should be a dead giveaway. Not to mention that if you're looking at, no matter where you're at, if you're looking east and you look at these stars, they diverge away from you going west, converge going east. And if you look just a little bit each way, you can see that stars are going over 180 degrees away from each other in your field of view.
I'm so pleased that you said that. Listen, for me, the Big Dipper, Polaris is almost dead center over my house. And the Big Dipper goes around my house. I see that thing bend, it goes down, and it goes right up in the sky. And I've never seen a camera pick that up. And there's no way that that's doing what the other stars, they're all doing, all like that picture you've got there. They're all doing different things. I said to Trouble that months ago.
Yep. And another thing that a lot of people don't really notice, and until they, in fact, I don't know very many people notice at all. If you see this right here is called, sorry, my computer went off. I'm going to turn back on. This right here is called the Milky Way or the galactic rift or whatever you want to call it. You can see here that a lot of people, they think they see the Milky Way at night, wonderful. Nobody ever sees it like you do right here. But the funny thing is that people don't understand that the Milky Way splits, and what part of it goes around the southern pole and part of it goes around the northern pole. People just think it's one solid, thing that goes around like this. But it doesn't, it splits. And the funny thing is that on the south, it's 5 times brighter than on the northern disk. And I'll say that again. If you look at the Milky Way at night, if you're in the southern hemisphere, it's 5 times brighter than it is in the northern hemisphere. And it splits at the convergence zone.
Orion's belt is where it splits. Orion's belt is right on the convergence zone.
Right below it. Yep.
Equatorial equator.
Like? That picture looks like a firework going off or something. It looks like that, doesn't it?
The celestial equator is what they call it, the celestial equator. It's all these new words I'm learning.
I'm so pleased that you showed that, because I know that if you're in one, maybe things look round, but I never thought, because I just the Big Dipper, and I have this. I know it's in your perspective, like you've just said, but I've got stars doing all different directions. But if I turn south, they go east to west. But I've got this thing going round my house. I've got stars coming from the east and then mechanically going round. It's amazing, and I just I wish I could grab you both and bring you here and no clouds to show you.
Yeah, no, and that's the thing that I think is messing up a lot of even people that look at the stars every night. They don't see what other people see from a different position. So they think, oh, everybody sees the stars like this. And we don't. We don't even see the positioning of like you're talking about the Big Dipper going around. We see it at a totally different angle than you. So it might even look weird to me compared to what you see in your sky. And I think that's a big key to people opening their eyes to what's going on.
I've got something to add to that. I feel like, I can't explain it properly, but you get to America, and not everybody, but a lot of Americans get a stretched out Big Dipper. And in fact, that's not one of your favourite stars, because most of you don't see all of it, and you see some of it. And, if you want to capture a star or a group of stars like Trouble's doing or all that, you pick something. But for me, it's the Big Dipper. this thing is big, but it goes around my house. So we have to be in the middle of something here because it goes around my house.
Right. And it is because of where you're at too. That's true. You do see it all the time. And
Yeah.
I see it. I see it every night. It doesn't matter what time of the year. It's just a matter of what time of night.
But you would think that you'd be at the North Pole to, have Polaris underneath you, and the stars going around you. But
Well,
in England.
just to explain, I went to Denmark and I was expecting the Big Dipper to be even bigger going around my friend's house in Denmark, and it didn't. I had to go down her garden and go, and in looking at it, it looked over this field and it was going around there, and I thought, what? And then of course in America it's stretched out and big. So I've thought, well, we must be more north than everybody. But Polaris is almost bang. My house faces north, south, east, and west. It's a bit ironic, really, because I didn't buy the house for all this. We just got into what we've got into, research and watching with the sun coming up, very quickly, because we're not talking about the sun. But for me, if you got a protractor and put it on the row of houses next door, the sun comes up on that semicircle. You know, a semicircle? It comes up on anywhere of there, but it always heads to this track and goes across. It's the most bizarre thing, but it won't do that for Trouble. And she has to have the sun low in her sky to be hot. We have to have it high in our sky to be hot. It's just bizarre.
Well, yeah,
that's because I don't think our lands are in the right place for the map. I think they're slightly twisted, and I think the sky shows that.
For sure, yeah. Yeah, the whole idea with the 24-hour sun at the north, and they're trying to convince us that there's 24 hours at the southern pole, which I don't believe there is.
No, I can do 17 or 20. I just don't think 24.
And do you know what's for us? We're not the most northern, because you've got places like Sweden. Places up there further up, they can get almost 24 hours of sun, light.
Right.
But it's just like for you or Trouble, you have a few hours difference for winter to summer. In the summer, we have like 18 odd hours of light, and in the winter we have 6.
Well, I'm close to the Tropic of Capricorn, but if I go down to Victoria, which is another 2,000 kilometers south, they'll have massive. It'll be daylight till 10 o'clock at night. And sun up at 7 in the morning.
In the summer here, when we call what you said the equinox, the last bit of light the night before in the north, because it's almost like it's the most ridiculous thing, because we always think of the sun being south and all that, but the light is almost starts at 0 north, and then it goes round, and then at 11 o'clock, 11:30 at night, there's still that little in the sky of light, and then at 3:30 or 3 o'clock in the morning, the light comes back. So it's crazy in the summer. We're so different in the summer to the winter, like ridiculously different.
Well, and that's why I think my map describes a lot more as far as what's going on with the sun as compared to what they show you. So if I remove the star and I just show you the sun track, right, and you see it on there. So if you take if you take as far as the way the sun tracks around here, I'm trying to find my flashlight and I can't for some reason. This is crazy. Man, that's
Do you know what? When you look at time and day, a lot of people don't realise one of the first places to get the light is Russia. For us here, like the light, because Russia's so big, supposedly, it's actually hitting Russia. Nobody talks about light hitting Russia first. Do you understand what I mean? Like everybody's looking at other places but nobody really talks about. I suppose there's no research there either, is there? Really?
Well, and the same with the. I mean, I see what you're saying. You're saying first, as far as it comes around, or first as far as from the north.
Because I made a map, and I made a square map actually, because it was the way the light went. I just mapped it all out. I also thought that on my map there was volcanoes around the edges, because everything was different as I was looking at how the light came in. So I mapped it from the light times. But of course, they're times that they give us. But often those kind of things are quite accurate, aren't they? Apps and things, they're quite accurate. When they say the moon's coming up at that time, it does.
Oh yeah, well, it's not like they can't time it out. It's all mathematical, that's for sure. But it's not. That's the funny thing I think about the whole, sun, stars, and moons, and the eclipses and stuff. They've been predicting this stuff and saying what times and stuff things were going to happen for thousands of years, and they didn't have any concept of a ball spinning around another ball back when the Babylonians and the Mesopotamians and fucking Aztecs were doing all their stuff. So I don't understand why people think that the scientists of today that think they're spinning around a ball are the ones who came up with this, because they weren't.
Okay, the map I made looked quite like yours.
Oh, really? That's cool.
Yeah, my daughter just lost the loo then. Yeah, it's a bit of a shame really. It's all in bits on here because I first made a map. I plotted it all out to the light that they gave us through time and day, and it looked like that more or less.
See, in E's model, Antarctica actually exists down the bottom. As well.
Yeah, I think
may exist down the bottom still.
I do believe that.
How does it quite work though? Because just what it is we can only see for 3 to 5 miles, right, in focus, and the stars are in focus, so they're not very high above our heads. So if I'm seeing them only miles above my head, how is everybody else seeing them? Do you see what I mean? It's crazy. I don't understand any of this anymore. I've got more questions now than I did before.
Well, you say 3 to 5 miles. We've been told that for years, that you can only see 6 miles, but that's not true, because I can sit out there in a desert, on the road, driving on the highway, and I can see 50, 60 miles because I know it's going to take me 40 minutes to get to that mountain.
Yeah, but it's probably a bit out of focus, isn't it? We can probably see it, but it's not in focus. We can only see things in focus for so many miles. But then if you travel from here to America or here to Australia, the sun will follow me. So it's all...
Right. And you can see those stars across the sky for a long, long way. That's true. Yeah,
but people have noticed when they go up in an aeroplane, because I think they've lied to us about the cameras. So when they say or they say it's 25 miles away, it's probably 12 and a half real miles away. And so planes aren't going as high. And then when planes go that little bit higher, everybody's going, where's the stars? That's because they're above them. And people don't realise that. But I do realise that when you've got something up there, it's going to say I was on the moon. Wouldn't that be amazing? If I was looking out from up there, I'm going to see rather a lot from up there, even though it's only a few miles away or whatever it is. Because when you're up there, it's different, isn't it? It's just different.
Yeah.
You're not going to see the same thing on land, are you? The sky is just something so different.
Well, I will say I've seen a lot of high altitude balloon images of people taking, their cameras, actually really expensive cameras, up to like 180,000 feet, and they still see stars up there. So I don't know why people say that they don't see stars in the plane.
It's a Stratus one, and it's one of the only ones that's done at night time. I couldn't believe it because they said they were, I can't remember whether it was 16 or 21 miles up, something like that, but only that. And the stars were below the camera.
Right. Yep.
All of them. But basically, when the camera was looking at it, it's like, it's just there in front of the camera. So as the camera moves that tiny bit, it's like being in Star Trek. Everything's whizzing and whizzing because it's just there in front of the camera. But there were stars below the camera.
Like below the horizon, like the horizon was below them, or what do you mean below the camera?
Well, the camera is say 21 miles up, but as it's panning around the camera, you can see stars below the camera.
Wow!
You can see them down below. Yeah.
So I'm just gonna do a little thing on so you can see the track of the sun, and if it was summertime, I'm gonna try and show you what it looks like as far as why you have 24-hour sun up in the northern hemisphere and why you don't in the bottom, as far as, because if it's tracking around this blue line and you can see that all of this area stays light the whole entire time, but the bottom doesn't. As winter comes, I'm going to switch to these outside tracks, and you can see you start getting night, and that's why your nights and days are so long and so short compared on the winter.
Yeah, but the light and the sun are two totally different things. We have the light can come at 3:30 in the morning in the summer. Like I'm telling you, we're getting to the equinox, the longest days, but the sun won't turn up for 2 to 3 hours afterwards.
Yeah,
So
that's the
the
same
light,
down in
Well, and
Victoria too.
well, you
light
say
and
the
the sun
light and the sun are
So
two different.
Twi-
Well, okay, let me.
Twilight, dusk and dawn, they go for a long time before the sun appears or disappears. Yeah.
Okay, so let me just go through this real quick because the way you said that. So we all watch a sunrise and sunsets, and you see them. There's no real termination line. You don't have light that just comes. It's more of you have here. Let me pull this up better. So you have a sunrise like this. You don't get just light all of a sudden. You get a blueness, a dark blue, then it's a light blue, then it turns to more of a white, and then it starts getting into yellows and then reds and oranges as you get closer to the horizon. As the sun comes up, you get this it's more of a glowing, a cool light that glows above you, not so much at you. But as soon as that light comes up above, as soon as the sun crests the horizon, you feel warmth. And I can kind of explain, I think, why this is now, is because if you look at the way what I think the sun is just the representation of a fluorescent tube. A fluorescent tube is made with a tube that is filled with mercury vapor and argon, with an element that is just an electric element that on one side and one on the other. I'm going to make this sound weird, but it's just a connection between the two that electrifies the argon between, when you electrify mercury and argon, you create UV, ultraviolet light, which is not visible to the human eye, but they coat this tube with phosphor, which is a pure white powder. And as soon as that powder is hit with the ultraviolet radiation or the ultraviolet light, it creates a glowing, visible white light. It's almost the exact same as the moon does because it's pure white. And if you look at the way that how can I put this? If you look at the way that the atmosphere is made up of nitrogen, 73% nitrogen, 24% oxygen, 1% or 0.9% argon, 0.3% carbon dioxide, and all the other inert gases. But the main thing is that nitrogen and oxygen, if you boil them and distill them, they create argon. And those are the biggest amounts of gases in our sky.
Can I say something? I've not filmed anything like You in Trouble. You in Trouble have spent hours looking at the sky and the light and the sun and everything, and I haven't, right? I've watched it, but I haven't filmed it. But I've watched loads of videos again, because that's what interested me at one point, was looking at high altitude balloons. And it seems that when the light comes, it looks like a gas. And if you could just take this away, look, you know, when you get Count Dracula and that mist comes out and it sort of swirls around, and that's what it looks like. It looks like this gas comes in, but in the gas is light.
There you
can
go.
see it changing colour. But the light here comes a few good hours before the sun. And then when you look at those high altitude balloons, it always looks like the sun is coming out of the ground.
Yeah, kind of, yeah.
And what I'm going to do is,
So if you
when we finish the E1, I'm going to just send you a link of somebody, Stan Smith, because you might be very interested in what he's doing. He uses a VR headset, and he puts all his... Stan Smith, you know who he is?
No.
He puts all his pictures into a VR headset, and it totally changes everything by doing this. And you can see that the sun and the moon are coming, they all cut the stars, everything comes out of the ground and goes into the ground in our perspective.
Yeah, and I could see how that, especially at a high altitude balloon, that would be that way.
Yeah.
You start putting it in like that. So, okay. So if you think about the gases in the sky, these are the inert gases. The only one I don't have here is I don't have oxygen. I don't have I got nitrogen. I don't have no, I don't have nitrogen, but they're blue. They're both blue. But if you look at this, these are the gases in the sky: xenon, kryton, argon, neon, helium, and then you'd have nitrogen and oxygen, which are both a blue. They're like a little bit lighter blue than this part right here in the argon. But if you look at these are tubes filled with the gases I just named off: the xenon, kryton, argon, neon, and helium, and mercury. So these are the colors that those gases will produce with mercury vapor. And the funny thing is that if you actually start looking and you look at these colors, and then you switch back to a sunset, and then you switch back to the colors, and you switch back to a sunset or a sunrise, they're the exact same. And if you look at the way that they actually produce the light, they're done with ultraviolet light. And if you think back to how I said the fluorescent tube is made, you know, it's an electric element running through gases of mercury and vapor, and argon to produce the ultraviolet, which is just like what you described as the sun. Doesn't seem like you have light. You said that it seems like light's different than the sun. And that's exactly right, because if you look at, this is a magnet in a coil. If you put a little bit of electricity in a magnet, in the coil with a magnet in there, it'll levitate. But if you put a little bit more electricity in there, the magnet will glow as it levitates. And that looks kind of like the sun to me. I don't know about you, but that's what it looks like to me. So if you take that and you think about that being the element in the sky running through all the different argon, nitrogen, and everything, you would think, you can kind of see how that's what we're getting. We're getting an electric element flying through the sky that is warm and hot, but as it's producing, and the funny thing is the closest body in the sky, what they say, you know, from time immemorial, is that Mercury, a heavenly body of Mercury, is flying up there next to the sun, the closest thing. And all you'd have to do is heat up Mercury to past, I think it's like 100 degrees, and it goes vaporous. So that's where I think we're getting our Mercury. You actually have a UV generator or a fluorescent tube element sitting up there going across the sky. It's giving us our light, like you said, our ambient light that has nothing to do with the actual burning of the sun. And then once the sun crosses the horizon plane, then you get your warmth, the actual electromagnetic burning element coming up to give us our warmth.
Can I just say something? When I was looking at my research for, I don't know, just looking at high altitude balloons, it's really crazy because when you or Trouble take a picture of the sun, it does look like it's in the clouds. But when you go up in one of those high altitude balloons, the sun is in the black and there's no light around it. It's in the black. It's above the light. And a lot of people don't realize that the light, okay, is these gases and that, but it's also working with the fact that we don't realize that the land is just as reflective as the sea. And that helps reflect this light back up because it's just like a big glow. We're glowing as well from we're very bright. The land, the sea, whatever it is very bright. And that helps create the light up. But the sun is above that in the black and there's no light around it.
Yep. You're talking about this right here, right? You're talking about the image where it shows and that's why I think, and you can kind of see that, like what you said, it's in the black above it. It's riding above, I think, above the gases. And no, for sure. I think there's a layer up there. I don't know what the altitude is yet. I mean, I could guess, but it seems like it's riding right above the layer of the Earth, and it definitely, what they would consider Earth shine, it has something to do with the reason that we do have our ambient light, for sure. I mean, there's no ways around it.
It's so crazy, isn't it? To I mean, obviously you understand that. I'm pretty sure that Trouble does and Patricia does. But it's so weird to explain to people that we are really, look at those high altitude balloons, just look down and see how everything is reflecting everything.
Mm-hmm.
And helping to create that miles up, however high it is, because I mean, we can only drill 8 miles down. So maybe we can only actually go 8 miles up. And so the planes aren't flying at 37,000 feet, which is supposed to be 7 miles. They're probably flying at 3.5 miles. But, you know, I mean, everything's not what they said anyway, so.
Yeah, no, that's for sure. I mean, I'm not sure about the distance of the heights of the altitudes of the plane, just because I really don't know, but I've done
If
a
you
lot
have
of.
time, Enslaved by No Media, he explains it on his channel. I'm not sure if he's explaining it today, but this time last year, he was going through video upon video. And in fact, he did these films where this sign was a mile away, and he actually had to do things to his camera, and actually the sun was closer than the mile away sign in his camera. It's most bizarre. What we're living in is the most bizarre thing ever.
That's funny. No, I do think there is something to be said as far as the whole atmospheric, altimeters and stuff, because altimeters work off of the barometric pressure. That's how they work, as far as they get a barometric pressure at sea level, then they go up from there, and then they say, oh, I'm 14,000 feet because of the pressure of the air. Well, the thing is that I've seen a few times of planes. I mean, all of a sudden, halfway through the day, the planes that are landing on the air base that's not too far from me, or at the airport that's about 20 miles away, they are so low to the ground. It looks like they're 2,000 feet or 1,000 feet off the ground. And I'll be honest with you, it's when we get major like low pressure or high pressures coming through, and it's usually when the low pressures come through, that you see the planes just all of a sudden they dip. And it's like all of a sudden the barometric pressure changes so dramatically that the plane's altitudes have changed as well, because they should not be flying at 1,000 feet off the ground. That's for sure. I'm talking,
Yeah, but even
commercial
those,
planes.
that's all a bit weird, isn't it? Because I actually put a video out the other day about a lorry driver. He let me use his video. This is from last year. And he was basically showing what would happen if he put his foot down without slowing the lorry down properly, even though he got bafflers in there. This liquid whacked the back, the fuel whacked the back of his truck. The whole thing about flying is really weird, isn't it? The whole thing. I mean, a lot of people don't realise that we're only doing about 100 miles an hour when we take off. I mean, it makes you feel like you're in a jet and you're waiting to go into, what we thought was space. Oh my goodness, like the thrust. But really, it's only doing about 100, 110 miles an hour. So nothing is right, and they haven't told us the truth about nearly anything.
No, you're just swimming. It's I've always said this before I ever even thought of the flat Earth, was we are the bottom feeders on the ocean of air. And we are. I mean, if you look around it, the birds are fish. We're the crabs and the sucker fish. We just eat up the junk on the bottom of the sea of air. So yeah, I think you're onto something there about the whole flying thing, because it's actually a lot less than that. I can actually get airborne in a Cessna at about 70 miles an hour. It's 85 is what
Yeah, smaller planes are 70, 80 miles. But you know what? Yep. I had my last flight, I actually went to Holland. And they said that the flight to Holland, North Holland, was going to take an hour and a half. And we did it in 45 minutes. And I was like, because I went to the loo and I said, what do you mean? The seatbelt sign came on. And I thought, she said, we've made up time. And I thought, how could you if it's 300 or 400 miles away, how the hell could we make up for that much time? 10 minutes maybe, but half the journey. I was like, I filmed it. I've got the video of it. I was like, it's her saying we're about to land. And I talked to her and I say, why? And she said, we made up time. And I thought, how can you make up 45 minutes?
Yeah, why didn't you guys book the flight as being that much time in the first place? Jeez.
I know, because what it is when they give you the time of the flight, they're not saying, hey, that's the turnaround and in case we've got a few problems. That's supposed to be the time, the length of the flight.
Yep.
So again,
there's all types of problems with those planes and ships.
You get more and more confused, don't you? I mean, that's probably why Trouble started talking to you, because she was like, what is going on in my sky?
Yes.
Well, I'm really glad she did, because she definitely was an eye opener to what's going on. Just the fact of the matter that she is deliberate in the way that she takes her pictures. She uses the same same area, so you can use the same trees and the edge of her house, things like that, to picture where things are moving, and to have so many different, 6-7 months of different star patterns or star trails is just amazing. I mean, it showed me what was going on in any way. It made me feel like I think I know what's going on anyway.
Do you know the one thing I did? Do you know the one thing I did notice as well with mine? I'd been watching this Big Dipper go around my house for a couple of years, and then, like, it was last year, the time that it was there had completely changed. What I mean is, for 2 years, say 8 o'clock at night, it was going past the left side of my house, and then last year it wasn't there at 8 o'clock or anywhere near 8 o'clock. I was like, wow. And also, again, this is just diversing because it's Trouble's hangout, really, but I watched the moon, right? Someone was telling me that on these equinoxes, or the Tropic of Cancer and the Tropic of Capricorn, the sun will always race through the sky. And he said, watch it. I actually had this person on the phone, and the moon came in really fast, like with your naked eye, you could see it moving. And it went a bit south, although it was going west, but it was slowly going west, and it was fastly going south. And then it was like, it almost stopped. He actually had the time. He actually told me the time to watch this. And then I watched the moon pick up these stars, bring them north, almost like drop them off, and then carry on west. But the thing is, everything was still moving, but the stars weren't going at the same pace as the moon. And the moon just...
Oh, no, not at all, yeah.
And then when I worked out the sine wave it was doing in the sky, it was a heartbeat. Dun-dun. That's what it did. Dun-dun. And I've watched it. I mean, we are so cloudy here. I do envy you two because you probably have much clearer skies. But I watched it twice in a month. And nobody talks about this. The moon helps the seasons. It drags the stars around for us. And nobody seems to know this. When you next see the moon racing through the sky at night, because that's probably the best, because obviously it's got stars then, just watch what it does.
Oh, no, go ahead.
Oh, you go.
Well, I was going to actually contradict what she just said, so I was going to be bad. Go ahead.
No, yeah, me too. You go.
Well, I was just going to say, if you the problem with saying that I mean, I so know what you're saying. I look at it as the track of the moon is the same as the sun.
I saw the moon go in, and the stars were all going at a certain pace because I was watching it before the time. But when the moon was there and it went north, it just went almost like directly north. It was still going really fast, all the stars. But you see, I didn't have a 360 camera. I wasn't filming it because I thought, if I just film this out the window, no one's going to get what I'm talking about. I needed a 360 camera. We needed to see what was going on and everything. And I didn't have it. So I can't prove it. But I saw it once.
There's those times of the year where the sun and the moon swap tracks. Like, and they do literally, like, for most of this year, I've been watching the moon rise, and when it's full, it's been more south, and then as it becomes like a crescent moon, it moves towards the equator, and then as it fills up, it goes back south. But in September, it was a full moon down south, then it came back to the equator as a new moon, then it went north and turned into a full moon, and then comes back to the equator as a new moon and north for a full moon. And so I presume it's going to do that for the next 6 months. So you might have been on one of those nights where it swapped, where the moon sort of didn't go back. It kept going north.
Well, no, she's talking about this. She's saying that she's here and she's watching the stars go across like this, like go around, and they're doing their circles, and the moon comes through just like it does. If the moon is on these circles, they're going to go, the stars are going along, the moon comes with the stars, and then it cuts away from the stars, is what she's saying, I think. Is that what you're saying, Karen?
Well, if you could just see it like there's a window to the right of you, right? Because that's where I see it. And the moon, I said the semicircle, a bit like you've got your drawing there. So you see those tracks on your drawing? Oh, I said, let me put your drawing up while I'm talking, because they don't see it. So
like this.
I was going to...
No, oh, okay.
So that they see it.
Okay.
So if you see that's the semi... Oh, it didn't work. Hang on a second. Let me just put it there for them to see. Right. If you see that those lines on the right are part of that semicircle, the sun or the moon could be coming on any one of those outer bits, but it always goes to this track. But with this night, the moon came in. It sort of went. It was going west, but slowly west, but faster south. And then it went on like that for 20 minutes, half an hour. Like it went right across the sky really quick. Then it just suddenly started to go north. And when I looked, all the stars were going with it. All the stars were going north with the moon. And then that went on for about 40 minutes or an hour. Then it stopped, almost like if you understand. And then the moon just went west. And the stars were there, but they weren't going as fast as the moon then. Because once the moon had sort of started going west, they were going slower. So the moon went off faster than the stars. But for that hour, 45 minutes, they were going as fast as the moon. And the moon was going really fast. I haven't watched it again because you need those times and dates. You know,
Yeah, because the moon's in different places each night.
He told me the time, and twice in 1 month, I saw exactly the same thing on both the tropics of when that was when it was happening. But you need a nighttime really, because if the moon, well, you can see the moon moving past in the day, but you want to see the stars, don't you? That's the whole point.
It does.
That's the only way to know where it's moving at. But you're right, that's exactly what it does. And on that map, that's what I was trying to show. So if you watch this, you can see that if you're following the red line, it converges or actually goes through the star trails, but right when it hits here, it's going with the stars. And then it diverges, like you said, goes west. I mean, this is west on my map. I know it looks like it's north, but it's not. And then the stars keep going around their track this way, but the moon diverges away from them.
Yeah, I do appreciate that. I've only got a small window of sky I'm looking at when this is happening. But when I worked out, when I drew out what the moon did, because you almost have to do it because you don't believe it, I thought, oh my goodness, that's a heartbeat wave. It went down further south. It came up north, but it never ever goes over my house. Neither does the sun. I mean, I know they're not quite next to my house, but my perspective, they're next to me. They go past they even might hit my neighbour's. The sun and the moon might hit my neighbour's house, but it never ever goes over my house. And then that semicircle thing, a bit like those lines there, the sun and the moon can come in. So in the winter, it'll be south for us, and in the summer, it'll be north. But it always goes across the sky, meets this track, and goes across.
Right.
Yeah, see, the moon and the sun go over my house. Like the moon was going over my house for the last 6 months, and now it'll be the sun. The moon's gone further north when it's full, and then it's harder to find it when it's a new moon. So they'll be closer to over my house. But it's just completely.
And it's great to hear you guys saying this too, because the way Trouble described it to me, it was almost perfect with the green, you know, because of the way that everything tracks across the top of her for, you know, the moon does it for 15 days and it switches, and then it does it the full moon every 6 months, but the sun does the exact same thing. And then to hear you say it about, you know, it changing the way it does, it's what I'm thinking is happening, and it's good to talk to people and see what's happening around there.
Yeah, so see the picture that I've got on my screen is that's the celestial stars, and so to the left of the picture, that's south, and that's actually Jupiter and Saturn, that bright white line. And then it goes to this celestial equator as you move to the right, and then to the right further is the northern sky. So yeah, it looks to me like, Jupiter and all the planets after Earth go around the South Pole. That's what it looks like to me. But the moon and the sun cross over. They've got their own thing happening.
Also, me and Trouble have talked about the fact that we're probably not the way that they say we are. So she's probably on top and we're down below. It's the other way round as well. So how does that work? And it makes sense because she gets a hot summer when the sun is in the south, low, and then that goes south for me is low in the sky, but it's cold. So it means that Trouble's got to be somewhere over there because of how it works for me.
Well, yeah, but it's more like you also have elevation too. So you do see the rings, right? So if you looked at them on the side, they're actually elevated like this, at least in my mind. They're elevated like this. So during our summer, the blue line, the sun's way high. And then during the green, during summer or during trouble summer, the sun is way low. As far as, you can see that it would track up during up in here and then would fall down low. And that's how it gets to where you see it drop so it falls off of a cliff. It's kind of seems that way in our winter, but it's just
But in a
the angle.
sense, she is south of me, isn't she, on that map still? She's still south of me.
On mine, yeah. Here, I'll move the.
It's just crazy because it does nothing like they tell us. I mean, Trouble's like, it gets annoying, doesn't it, Trouble? Because you want to know it. You want to really know what it is all.
Yeah. Well, because everything's about the Northern Hemisphere. Even when I look stuff up, they'll still say that they'll give the dates of this, of summer, of the what's the longest day and the shortest day called again?
The solstice.
Yeah, and they'll be completely wrong from my end. But that's even on the internet. That's what they give you. They don't even explain. Nowhere is there a mention that it's the opposite in the Southern Hemisphere. They don't even talk about us. It's like I have to flip the information constantly.
They've done that on purpose, so haven't they, Trouble? To make it look like you're so far over there that we'll never, like Russia, it's the same bit. The areas where we probably need to go to do some research, they're pretending like you almost don't exist and you're so far over there. We can't connect with you because you're so far away. That's how they've done it, though, isn't it? We don't really go to Alaska and do it, do we? I mean, I know people live there, but that's a sort of place where maybe we should all be setting our cameras up. And Russia and
I lived there for a year and a half.
Yeah.
I lived in the Arctic, right above the Arctic Circle, 61 parallel.
Shit, was that cold?
Yeah, I saw 71 degrees below zero Fahrenheit.
Oh
my goodness.
No.
Yep. I got to do the whole thing, where you take a cup of tea or whatever. I just did hot water, walk outside, throw it up in the air, and nothing hits the ground.
It's cool.
Yeah. But, okay, so one thing I have been working on, and I think it actually shows that one of the reasons why there might be a big disconnect of why everything is the Northern Hemisphere. You only talk about this. And NASA only, or the governments only, the IPCC, any geological people, they only talk about pretty much what's going on up here in the northern. And if you take what I think is happening with the planets, and I mean, I can't prove this stuff yet, but this is the positioning. If this is the North Pole, this is the Southern Pole, this track is very small compared to what it is actually on my map, but you can see where the planets are. You got Jupiter, Saturn, Pluto, Uranus, Neptune, and then Mercury, Venus, and Mars. If the sun is that like midnight position for me, as far as on my map, the sun's right here. So it'd be almost noon for Hawaii is what it is. But that means that in my mind, the southern quadrant or the southern area is the actual driver of the world, of the electric verse, the skies above us, because I now believe that the planets are a grounding or the metric of how the sun works. The sun heats up and cools down in a cycle of 9 to 11 years, but seems to do that as far as it gets hot. We got really hot summers and then we get really cold summers every 9 to 11 years, but it seems to do it in a cycle of 248 years as far as to go along with Pluto, to go along with Uranus, Neptune, Saturn, and Jupiter. And the funny thing is if you really start looking at the times and dates of when these supposed planets go through their cycles of the same cycle of the Analemma of the moon and the sun, but Jupiter is 11 years. And that to me was the driver that showed me that if you look at that, this is 11 years and the sun goes through its cycle every 11 years, and where Jupiter is now, we're in a solar minimum. If you change that back around to where it's in its height, Jupiter will be right next to the sun when it's coming around, when it's going through its cycle. Right now, it's exactly opposite, so that it's opposing. And what I think is happening is that these planets are grounding the electricity in the sky away from the sun. As soon as they get out of this pattern, we'll have a hot, winters again or whatever. But what it looks like is if you go back through like the 1600s, 1812, 1888.
They've got us down for an ice
summer.
age, haven't they? They're fearing everybody with an ice age.
Yeah.
I mean,
exactly
something has happened to us, though, hasn't it? Because there does seem to have been some kind of flooding.
Well, and
No, well, they
I
say
want
we're
to show
going
you
to a
one other
heat
thing
age.
too.
And I think we're going to have an ice age, not a heat age. That's what I think. I think coolness is coming.
And I want to show what I think an ice age is. It's because we've been told that an ice age is that if you take the other maps, say the ice just came down.
Can I say something very quickly? As you've just gone off that picture, you can see why the native Indians and all these people thought that we look like a turtle, really, by looking at your drawing.
Oh, for sure. You see this and this symbol
and
everywhere across the planet. Everywhere.
So they know more than we do.
You even saw this symbol all over caves everywhere. That is a very, very point too, is that the American Indians and all the different ancient cultures, they knew stuff we didn't know. They had to. But so they explained to us as an ice age is when the ice age happened is that everything got cold and the oceans just got all messed up, and it was something happened on the earth, and so ice came down and just covered all the way down to here is what they say, right? Well, that's not so much true, and I can show why it doesn't happen that way and what has happened and what's happening right now as far as that goes. And the reason is because if you go to my map and you show the geological what has actually happened during the ice ages, I don't think it's so much that the whole world gets ice. To be the Arctic, Antarctic, so you're just watching this white area. As the magnetic pole moves, and it's moving at a rate of like 20 miles a year right now, and it's moving this way, exactly how I'm going to move this. If the sun's track moves just a little bit down here, you're going to have an ice age to where ice is going to cover all of here. It's going to, the whole Arctic is going to move down across, England, Eurasia, pretty much down to the 40th parallel, 41 parallel is going to be cold, all the way through America from the continental divide down through the east, through Florida. And you can see that it's going to warm up Alaska as it slides down. It's going to warm up Alaska, California, and Australia is going to get warmer, more droughts. You're going to have more water coming through a lot of places, like through Africa, through India, places that just never seen water for 2,000, 3,000 years are starting to get water. Exactly what happened with the ice age is that the ice caps covered all of this area, all through here, and then receded afterwards, recede back up to being what we have today is just the ice caps where it's at now.
It's been fascinating. And I like the way that you explain things, and it's really nice to meet you as well and listen to what you've got to say.
They say the pole stars, haven't changed for thousands of years, or if they have, it takes thousands of years for it to happen. But the North Pole seems to move, and the South Pole seems to move.
Hey, Trouble, do you remember when we did do some research with Ceres? He reckoned that the magnetic poles, because there's 4 pillars as well. He found the 4 pillars. The ones in the north move more than the ones in the south.
Yeah. And
So that's why they magnetically move around more than, that's what he said.
That's interesting.
Yeah, I mean, I've got a few of those videos, and obviously not today, but Eon, I might be able to just show you, you know.
and then you think about it, you think, well, our
Yeah,
compasses
yeah,
would
for
change.
sure.
Like that would change the latitude and longitude of everything on the planet, you know, on Earth. And then E1 was saying, well, they do. They have to update the airports for their
Yeah,
location because the
yeah.
North Pole keeps moving.
When was it? It was in
Magnetic pole.
It was in '94. They changed all of the runway headings across the world, and they're going to have to do it again because of the magnetic north moving so much.
Didn't they
Back in
have to
18,
do that when they
let's say,
said, didn't that sort of an earthquake happen, and they said that all the runways, like, they had to change them? I mean, we never know whether that's true anymore, but they did. Only so many years ago they had to do it.
well, and they'll be
Because of
doing
an
it again,
earthquake
yeah.
or something. It changed everything. But they're lying.
Well, I
It
don't
is
know if
changed, but it didn't
they
happen
might have went
because
along and said something like that with an earthquake, but I don't think that's the
no,
reason. I
but
mean,
they'll tell
it
us
is,
that, but it won't be the reason. But they've got to say that because they've got
yeah,
to lie to us.
that's right. But right now, it's like in 1850 or something, the magnetic north was over Canada, actually over landmass, and was way south or west, however you want to look at it, from where it is now. In the last 10 years, you could actually, let's say from 2001 to 2010, you could actually stand there and take a picture and see the stake for every year where they put down where the magnetic north was positioned to be at on the Arctic shelf or on the ice. Now it's moving at a rate of over 20 miles per year. It's probably even faster. That was 2 years ago. It was 20 miles a year. So if you think about that,
Can I add something to the mix as well, then? Can I add something to the mix?
Yeah, yeah.
What I noticed was I did a lot of research with someone, and we did all this. We were looking at Google Maps pictures, and I couldn't believe that in Greenland they had T-shirts on, because they've always told us how cold it is, and these people live it so desolate. Now, I'm not saying it can be as hot as here, because I remember some Americans coming over. It was April. My kids had shorts on, and these Americans said, "Oh my God, those kids have got shorts on." But it was obviously hotter where they'd come from. But these people were in shorts. They'd been swimming.
Not necessarily.
They'd been swimming in the, yeah, not all of America, but obviously where they came from. But they'd been swimming in the sea. This is what Google Maps was showing you. Then what it is a lot of people don't realise that Denmark has sovereignty over Greenland and the Faroe Islands. And the Faroe Islands are above the UK. They're above the Shetland Islands. And then I looked at pictures there, and they also were wearing T-shirts. Now, my daughter-in-law comes from Lithuania. Now, Lithuania is not far, well, it's like on the Baltic Sea. Now, we always see that as ice. In the summer, for 8 weeks of the year, they all go up to the beaches up there. It gets to 40-odd degrees. It's really hot. And then someone else who lives in North Canada, Mikey, he's been on our Hangouts. He's on a Facebook friend as well. He lives quite north in Canada, in the middle. And for, say, 8 weeks of the year again, it gets really, really hot. And they never say, not worldwide, that these places ever warm up. It gets really cold winters. But I'm saying in the summer, it's the opposite. It's really hot for so many weeks in the summer. Obviously, very cold in the winter. But he reckoned that if he kept driving north, it would just get hotter.
That's funny. Well, at a certain point, I will say that I've seen 90 degrees in Alaska during the summer, and I was up above Fairbanks, Alaska, and it was 90 degrees. So I don't know what people are saying about it's never hot, but I will say this too. There were times that it had been 50 below zero for 2 weeks or a week, and then all of a sudden it was -10, and there were people walking around in shorts. And it's -10 degrees Fahrenheit. So that's what, negative, I guess it'd be like -20-something degrees Celsius. But I mean, it's cold. It's really, really cold. And they're walking around in shorts and T-shirts and just all, yeah, isn't it a a hot, musky day. And I mean, it's like, oh my God. And they're just so used to the cold that to them, that is hot. But it does get hot there. I'm not trying to say it doesn't get hot.
What I mean is, it's just a misconception all the time of information we're given. So I actually thought that there's just hot places and cold places. Like we don't know what Antarctica is, and some say they don't think there's much land there anyway. But it's a bit like the Andes is cold in a hot country, and then you've got the Alps in the winter, it gets very cold between two hotter countries, and then you've got Everest in a cold is very cold in a hot country. But if you were taken to these three spots on Antarctica and taken to the Andes, the Alps, and Everest, and someone said it goes on for thousands of miles like this, you'd believe them because it looks so cold. But you're only being taken, but behind it could be really hot. And you also know, don't you, with mountains and things, that, you know, when you're going up the mountains, like you say, it's cold, but people look at, like in America, they go skiing up there and they've got to wear goggles and jackets, but down below they could be could be in a bikini.
And also the other thing is, if the North Pole's on the move, it could explain like how we've got those woolly mammoths frozen mid-step. Like, you know, a freeze must have come over very quickly compared to where they were. And
well, and that's where we already have proof of that. That happened 2 years ago in Russia. It's just like what you're talking about too. I don't think it's because of, you know, the North Pole moved like that, you know, and froze everything, but that is the what would it be? The action that's causing that is what's caused this. In Russia about 2 years ago, a storm came through or something came through. Nobody really knows what happened as far as what to call it. But they found bunny rabbits or hares frozen in almost midair, jumping through fences frozen. They had wolves that were running with their eyes open and their tongues out, frozen in the middle of fields. There were caribou that were just
Can I just say as well, I was going to say, somebody was talking, I can't remember if it's somebody that told us or I was watching it now because we've been through other hangouts and doing other videos on another channel, but it was about Sweden. So Sweden can be really hot, but then within like overnight, it can go from one temperature to another, just like you were saying. So I don't think they understand what it is. 1 minute it can be, well, someone's moving around. Who's moving around? Yeah, anyway, it can be really hot and sunny one day. That's okay. And then it can be complete opposite weather the next day. So obviously you know, we're not aware of how much our weather can change. You just think it's the UK it happens. Because one day we can be hotter than you and trouble, and the next day we're snowing.
I think it depends too where you are on the circuit of you know, like the supposed magnetic North Pole moving. You know, like it does from looking down on a map, it looks like, you know, it does a nice round circle. But where you are on the ground, it could be moving like slowly east, and then it's going to, you know, come a little bit south and then swing back around west. So it's going to seem to appear to hang in that same area for quite a long time. But for somebody else, it'll just be whooshing straight past, you know. So maybe that's what's creating all these, you know, different things happening in places that are so close to each other. If that makes sense.
Oh, it could be a number of different, just a bunch of different things stacked up together to make like a wave of propagation, you know, to where you've got the sun doing that, you've got certain planets doing this, or jet streams that change, and all of a sudden, bam, you've got a recipe for disaster. I will say, though, if you
something
look
else
around,
I've noticed as well, like this change, I told you that the Big Dipper was coming up at a different time. It was in the sky. It was still going there. Anyway, I noticed that for 2 years, the moon, because my window faces east, but I have quite a good view, and I saw the moon coming, like it was either on the south of my window or on the north of my window, but I could see it. And then last year, I hardly saw the moon. I mean, we have clouds, but it was much more south last year. So I noticed that when the moon starts going a bit more north, even in the winter, it makes the weather change. The more north the moon goes, it's all bizarre. I find it absolutely bizarre.
Yeah, it goes, it sort of, it bounces back and forth as it, you know, from full moon to new moon. So it does this back and forth thing, as well as that whole back and forth thing, slowly moving north and then slowly moving south. Slowly. So it's got quite a
I
few
don't get
different
that though.
movements.
Like for 4 or 5 days, the moon might come up really north and then it's south again.
Okay, so I can show you why if you want me to
Go
try.
on then, yeah, please go for it.
Okay, so it follows the same track as the sun. Okay, so the sun and the moon go around the exact same track. So this is the sun. We'll do the sun red, the moon blue. The sun, if it's going through, will take the sun. Sun will take 1 year to go through the whole cycle of its track from blue to red to green to red to blue. Will take 1 year, if that makes sense for its full track. The moon itself takes 29.5 days to go through its track. So in 14 days, the sun or the moon will go from its northern position. You know, it takes 1 day to go, or 23 hours to go around, or no, I'm sorry, 24 hours and 56 minutes to go around. But to go through its Analemma track, it takes 29 days. So in every 2 days, the moon is going to move almost a full hand. So the moon will only take 14 days to go from its most northern position, as far as if you're looking at it as it's already rose up and you're looking at its way north, for it to go to its full southern position will take 14 days. So it moves really quick compared to how the sun moves in its position in the sky. Does that make sense? Do you see what I'm saying or no?
I do. And it's very confusing because it's almost as if we're missing a month anyway, because if the moon's doing these 13 cycles, we probably had 13 months originally, not 12. And I think that's why everything's changing. Because slowly it is changing, because there should be 13 months and there's 12. And what it is we're all noticing it now.
It's 12.65 months, yeah. And that's the funny thing, is that if you look at the stars movement, the stars movement is faster than 24 hours. The sun's rotation is 24 hours. The moon's rotation is over 24 hours. And it's really weird that you can look at the stars and they move 1 degree faster every day. So the sun comes around and does 1 rotation. The stars do 1 rotation plus 1 arc degree. And that's something I'd never been told. And if that's true,
You know what?
it's exactly what you just said.
If I had to explain what it was like up there, I said it was like a merry-go-round. And in a sense, even though it's slightly different, and today it looked more like a firework, I understand now. I understand it much better from the diagram. So thank you so much for that.
Oh, you're welcome. And it's exactly like it's a merry-go-round with the wheels and the high key turns. It's exactly like what it is.
A mechanical merry-go-round.
Yeah.
It's the most ridiculous thing. You've got to use the word a round. Round makes it sound like it's a circle, but it's not. But it still goes a round. That's the only words there is.
Right.
But it's mechanical, and it's like your star trails on that picture thing, on doing all those different things and looking like a firework and do. That is exactly, because sometimes I've watched Orion's belt go north to south. It just goes straight past my house south. And other times I see it in another place doing something else. But it would make sense then, because it depends where I'm picking them up, what time of the year, where they are on the cycle, the whole thing. Woo!
Well, in those star trails, like the stars are set, but then you've got the sun and the moon coming in and doing different, their own little things. But then you've also got the planets. And I think the first 2 planets are tied to the sun, so Mercury and Venus. And so I do think they go around the place around the sun. But the other planets, they go around the southern tracks, and they only just appear in the northern hemisphere and then disappear again. But I could see them going straight over my head every night after night after night.
I wish that we had the 5 times brighter starlight that the Trouble got, because I probably would be able to capture them into my camera then.
Now they're 5 times brighter in the Milky Way. in that area
Right,
in the Milky
okay,
Way
yeah.
is what I'm saying.
Yeah.
I don't think the stars themselves are 5 times brighter.
Can I
And
just
then
say that, can I just say that we've been going for nearly 2 hours now, and I just wonder
wow.
whether you would come back and do this again and we talk more, because obviously you've explained masses today. Trouble, we didn't get very far on your stars.
No,
But,
mine just ties in with it. He's got way more information. I just have the star trails. He's got it all. So
Yeah, I'll definitely come back. Yeah, for sure.
Should we just
I love talking about this stuff.
should we
yeah, me too.
should we just end the hangout in a minute, but say goodbye to each other after I finish the recording? Because obviously I hate just rushing off when we spent this time talking to you.
Yeah.
Sure.
Trouble. I mean, Patricia hasn't said anything. Patricia.
Hey, Patricia. I didn't say hello to you earlier.
Yeah,
Sorry.
she's a good
Hi.
listener.
Yeah, I did say hi to everyone, but I think anyway. Yeah, fascinating. I know we're supposed to be saying goodbye, but this is the sort of time that when I like to say stuff, because obviously I'm listening
Yeah,
to
what did you
whatever
think?
you're saying. So the little video you showed of the sun rising and all those different, what I could only describe as gases, you know, the different colours, reminds me of the rainbow, because it's the same colours. You might not see all of them, but it's that effect. So I was just wondering, well, just fascinated, because we get rainbows, don't we? But that's to do with obviously the sun and then rain following. And I'm like, so you've got me interested to look forward to next time, where we could maybe talk a little bit about that if you wanted to. But yeah, it's been fascinating.
Oh
I
yeah.
love it.
I've got a whole thing on rainbows for sure.
Have you? Brilliant.
Can I
Yeah.
say that on rainbows, people don't realise how low they are in the sky. And when I was in Denmark, I can't say it was a black rainbow, but if you understand, there were different shades of sort of darker colours, but there was no colour. It was just like shades of black in the sky. I saw it. I've got a
Yeah.
video of it. There was no colours in
I
it.
call them monochrome.
It was
I've seen
still a
those before.
It was a kind of rainbow thing, but it had no colours in it.
Yep.
I
I've
was
seen
like,
that.
I was going, oh my God, to my friend, look at that.
Wow,
What is
really?
that?
Wow.
Yeah.
Never heard
Obviously,
of
there's run out of gases in that rainbow.
that.
Yeah. And at the same time, a sundog came. And at the same time, they were harping the sky with these sort of Alka-Seltzer clouds going through the sky. But anyway, we will do that, Patricia. That'll be great. Trouble. Next, what do you want to say? Do you want to say anything?
No, I'm good. Thanks
Are you?
for everyone listening. Yep.
See what we've got through, and it's just about 8 o'clock in the morning. E1. Yeah, poor Trouble.
No, it's all good. Only one day.
Oh, bless your cotton socks. Sorry about that, Trouble. E1, that has been amazing. You want to say anything extra just for a few minutes?
Well, I really appreciate you having me on. I really enjoy talking about this stuff every time I do something like this. So just going through the presentation of things I have, I learned something new. And I've already written down about 4 or 5 things I can talk about next time that we can go over. So I got plenty of stuff to talk about.
Sounds
Brilliant.
good to me. It's a date.
Cool. Right on.
Just for the hangout, we're going to say goodbye. But we'll say goodbye. Don't rush off. We'll say goodbye when I've pressed when we've not recording. But thank you
Okay.
everybody for watching. That was very amazing, and I loved what you did. And 10-10 till we do it again. So
Okay.
everybody, goodbye from
Okay.
us.
Bye, everyone.
Bye.
Love you all. Thanks for watching.
Yeah.
Patricia, you haven't said the words.
Just said it then.
Oh, did you say it again then? Just make sure I don't cut you off.
I did it really quick. I thought she's going to cut me off any second. Take care, everyone. Love you all.
Yeah, love to
Thanks for
everybody.
watching.
Mwah.